In this video, I want to tell you the absolute basics about what we know about atoms. Okay, so recall that an atom is the smallest particle of an element, and so if you get any smaller than an atom, it's not that element anymore. And by element, of course, I mean all of these. Hydrogen, helium, lithium, beryllium, carbon, oxygen, those are all elements, and the smallest piece of any one of those is an atom. However, atoms themselves aren't the smallest pieces of matter that exist. Atoms are made of even smaller pieces, and maybe you know this already from an earlier year of science, but atoms are made up of protons, neutrons, and electrons. And here in this PhET simulation, we have the opportunity to use those subatomic particles to build an atom of whatever element we like. So in here, I can click these plus boxes to see some extra information like the charge and the mass number. And as you can see, when I put a proton in there, now I have a hydrogen ion. It's an ion because protons are positively charged. And once I balance that out with a negative electron, now this is a normal hydrogen atom. And you can see from this simulation some things that we know about atoms, that the more protons you have, the different atom it becomes. And as you add electrons, they spin around the middle, which contains those protons and neutrons. So this is a pretty basic picture that we have of an atom. This isn't what atoms actually look like, you should know. This is a model to help us understand where the particles are inside of an atom. In reality, things are a lot more complicated than this and a lot more difficult to visualize. You see, atoms themselves are smaller than the wavelength of light. So the idea of seeing an atom doesn't exactly make sense when you're talking about a single atom, because seeing requires light. And if atoms are smaller than light itself, well, it becomes a little bit more difficult. But with our language, we can still talk about what they look like. If you click cloud here, you'll see that the electrons become this hazy, ball around the middle of the atom. That's a little bit closer to our understanding. If you go to ptable.com and click over here on electrons, and you select various atoms, you'll get these pictures up above here. And you'll see that as we get bigger and bigger with the atoms, that picture gets more and more complicated. What we're looking at here, these are the electron cloud surrounding each one of these elements. And you can see atoms are all different shapes. They're not just little spheres. They're not protons and neutrons with rings around them. Again, this picture is just something that helps us to conveniently understand what's inside of an atom. These pictures here are a little bit closer to the truth of what all of these elements are shaped like. Okay. Now the colors too, those are just there to help you see the difference between the suborbitals, the clouds of the electrons. Okay. They're not really red and blue. Again, atoms, individual atoms are smaller than the wavelength of light, so, it's not red and blue chunks. Okay, let's get to our notes. I'm going to use this as a comparison item to talk about atoms, but right away from that picture, we can see that first thing that we learned, that atoms are made from 3 particles. So let's draw a picture of that lithium atom. That one had 3 protons. I don't know why, but protons are always red when you do these things. It had 3 neutrons. And then around it were 3 electrons. And I am terrible at drawing circles with these things, so maybe you can do better. First 2 electrons should be on that first ring. And the 3rd electron needs to go on to that 2nd ring. We'll talk more about that later. But for now, let's just put labels on these things. These are electrons. Red ones are protons and neutrons. And these three things are called the subatomic particles. Sub meaning smaller than an atom. Subatomic, smaller than an atom. Particles, as we remember, are just tiny pieces of matter. Okay, the ones in the middle, the protons and the neutrons, they're special. You should know that. They always go to the center of the atom, and the electrons are always outside of that center part, all around it. So that center part is called the nucleus. That has its own name. So I'm going to put that in a little box here. And we'll write down that word, nucleus. So there's some vocab that you need to know. Now, things about these subatomic particles. They have charge, like electrical charge. And charge comes in 3 different flavors. One flavor of charge is positive, and the protons are positive. And for that reason, when we write the abbreviation for a proton, we write P with a little superscript plus to denote that the proton has a positive charge. Neutral charge, you may have guessed, is the neutrons. That's why they're called neutrons, because they're neutral. And their abbreviation is a lowercase n with a superscript 0, because there's no charge. That's what neutral means. Not positive, not negative. And of course, negative is the third kind of charge that you can have. And electrons are negative, so we write an E with a superscript minus. Now it's important to note that in an element, in an elemental substance, these elements are neutral. Okay? The number of protons equals the number of electrons. So here in our lithium atom, we have 3 positive protons, and you can see that over in the net charge box, 3 pluses. And we have 3 minus charges for the electrons. You'll also note that lithium is number 3 in the periodic table. Okay? Lithium has 3 protons, and it has 3 electrons, and it's number 3 in the periodic table. That's all connected on purpose. Okay? The periodic table is built that way. Masses. The heaviest particle in an atom is the neutrons. Let's get this out of the way. My goodness, all sorts of computer trouble here. In fact, I'm just going to delete that for now. Heaviest is the neutrons. Protons are almost as heavy as neutrons. In fact, it's so close that we can say that they're the same, protons and neutrons. Okay? And their mass is 1 AMU. AMU is an abbreviation that stands for atomic mass unit. We'll write that down. Electrons have mass, but it's so small that it's almost 0. Okay? We don't count the electrons when we're adding up the mass of an atom. So an electron is tiny, mass is almost equal to 0 AMUs, and for the purposes of our class, because we're just practical chemists, we're going to call it 0. You should know in reality it's not 0, but it's really close. Okay? So for example, we have our lithium atom above, and we want to know the mass of this atom. Well, if we add up the masses of all the particles inside, that will give us the mass of the whole thing. The electrons we just decided were 0, so I'm not going to count those. Each proton and neutron is 1 AMU, so if I count them up, we have 1, 2, 3, 4, 5, 6. The mass of this lithium atom is 6 AMU. Okay? Lithium in pick above, 6 AMUs. Okay? Not every atom is the same. There could be a different atom of lithium, and you may have discovered this in our simulation, that you can add a neutron here and it's still lithium and it's still neutral. Okay? Perfectly okay to do that. Changes the mass. Notice the mass number now is 7, so the mass of this atom of lithium is 7 AMUs. Lithium with 4 neutrons, 3 protons equals 7 AMUs. Okay? So there are heavier versions of atoms. That number, the mass of an individual atom in AMUs, that's called the mass number. Okay? Earlier I talked about how lithium is number 3 on the periodic table. That one's called the atomic number, and I'm going to talk about that in the next video. See you later.